Good afternoon, and welcome to our webcast, Creating Quick Codeless Connectivity with Autonomous REST Connector, presented by Progress. I am your host, James Goodfellow, and I'm a Product Marketing Manager with the Data Connectivity and Integration Group here at Progress. Joining me today is my colleague, Ken Butler. Ken is a Product Manager here within the Data Connectivity and Integration Group as well. Hey, Ken, how are you today?
Good afternoon, James. I'm excited today to talk about this new product that we released. Looking forward to getting into some of the details and also showing you some of the capabilities today.
Excellent. Fantastic. All right. Well, today we're going to talk to you about an exciting new product that we're launching here at Progress called Autonomous REST Connector that will enable you to quickly, codelessly connect your application with any REST API. But before we get too far down the road, I do want to talk briefly about how we got to this point. And first, before I go too far down that road, I do want to say that we will be taking some questions at the very end, and we're also going to have Ken give us a very fine demo on just how easy and how powerful this new product is. And so if you have any questions, add them to the chat window, and we will answer them, like I say, at the end. And then after Ken gets his demo, if you have any other questions, just let us know. Great. Okay, so how did we get to this point? Data access has certainly changed a lot over the past few decades. We've gone from connecting one machine to another, then a network of data sources, and now, of course, we have a near limitless number of on-premises and cloud-based data sources that we can connect to. ISVs have traditionally had a limited sphere of systems to connect to. These include relational databases, data warehouses, et cetera, on-site controlled systems that didn't necessarily require extensive authentication or security measures. And to meet this need, ISVs have traditionally built SQL connectors that are ODBC and JDBC driven. Now, take a look at a common traditional SQL approach to data access. And Ken, I'm going to put up a diagram if you don't mind talking us through it.
Yeah, so SQL has been a common and traditional approach for decades at this point in time now. Enterprise applications for analytics, BI, and data management all operate relatively the same. Their application, the client, makes a SQL request using ODBC or JDBC to a backing data store, and the data is either returned, updated, created, or deleted. Now, there are a few common pitfalls when needing to support this model. First, each one of these applications has a set of users that are using more and newer data sources. REST APIs, cloud applications, operational databases, and so on. The list of sources that these users require grows every year, and it's hard to keep up, especially for our customers. Second, given the breadth of users, it can be difficult to maintain so many point connections across so many different data sources. Who is accessing data and what they're doing with it can be a hard question to answer. And most importantly, standardizing how data is being accessed, such as retrieving the list of current customers that are active, is almost impossible with direct access to the database, but made a lot easier using an API-first approach.
Thank you, Ken. I appreciate that. Now, we've all seen recently the reign of SQL access give way to REST APIs, and for good reason. And we'll talk about that going forward. As more and more demands are being made of our data sources, it becomes prudent to ensure the security and the integrity of the data, as well as those who are trying to access it. And I think this chart does a really good job of illustrating the importance with this massive shift over to APIs over the past 10 years or so. In fact, according to Programmable Web, who created this chart here, there are almost 20,000 public APIs currently available and in use. Additionally, enterprises are creating hundreds of thousands of private internal APIs. Organizations expect that their analytics, ETL, and ERP apps are going to seamlessly integrate with their major enterprise systems. And ISVs are allocating more and more resources to increase their out-of-the-box connectors and to extend support to the proprietary enterprise data sources that companies are using. While on balance, the shift to an API economy is a net gain for application developers, it definitely isn't without its challenges. ISVs face significant hurdles when it comes to accessing the growing multitude of public and private APIs. Here are just a few samples of the challenges that software makers are facing. First, SQL-based tools don't always work well with the REST APIs, and it can be difficult to access and analyze that critical data. Beyond that, ISVs generally don't have the time or the resources necessary to keep up with the latest data sources. And even if they can keep up with developing connectors for these sources, it is extremely cost prohibitive and nearly impossible to try and maintain them. And finally, these are often one-off use cases for customers, and there's no real scalable value proposition. For all these reasons and more, we have developed a solution that we feel addresses this very well for ISVs. And that's what we're here to talk about today. This is what we're introducing, the Autonomous REST Connector. Quite simply, it's an intelligent, customizable data connectivity solution enabling lightning-fast, codeless connections between your application and REST API data sources. And there are really four main primary characteristics here. First is SQL access. This product's going to allow you to query REST API endpoints just like a standard database. Two, the ability to normalize with the JSON results based on your specific relational schema. Three, what we're calling our secret sauce, intelligent sampling, which automatically interprets the metadata and infers the correct relationships. And that's where the autonomous REST connector comes from. And then finally, authentication. Now you have control over which data certain users have access to. It isn't simply everybody has access to it or nobody has access to it. Autonomous REST Connector saves you the time and the resources necessary to build and maintain those custom connectors. So, Ken, if we talk about that diagram that we looked at earlier, and now we slot in Autonomous REST Connector, can you walk us through what that starts to look like?
Exactly. So the more customers we talk to, the more we start to see that enterprises are really starting to modernize how they're allowing their customers, whether they're internal or external, to access and leverage their data. So this new approach is to really expose data as services as opposed to allowing applications or users to directly go to the data source. And this is really being done to standardize how data is being accessed from a governance perspective, but also allows for a standard way to consume the data using API calls. So if you take, for example, an enterprise that stores customer data in a relational database, instead of allowing each application to issue a SQL query, which may be performant or not, to the customer tables, they may choose to implement the REST API for requesting the list of customers. And so what this means is that traditional reporting, BI, and ETL tools that depend on SQL access can no longer effectively retrieve the customer data using SQL. And this is where Arc fills the gap. Arc essentially is this bridge between SQL and REST APIs so that there is no loss in functionality when enterprises and applications modernize to leverage the use of REST APIs or data services.
You know, there are a lot of benefits to this new approach, and I want to highlight just a few key benefits here. First, and this really cannot be overstated, connect any application to any API data source. This opens up really a vast world of possibilities for empowering your customers. Secondly, it's zero code necessary. And we didn't make this codeless because we meant it for everyone in the organization to use. We made it codeless to expedite the data connection process, to make your developers as productive as possible. And this allows your customers, data architects, data analysts, and data scientists to quickly access and use the data they need. This is the essence, in our opinion, of high productivity. And finally, building seamless connectivity is essential to real-time data analysis. Autonomous REST Connector is not only fast and offer an easy API connection, but it also empowers users to query API data as seamlessly as though it was through a native application. So from a bottom line standpoint, I wanted to use the analogy of a factory. Autonomous REST Connector is essentially a factory that allows you to rapidly build data connectors to your customers' APIs. No two APIs are going to be the same. No two connectors can be either. Autonomous REST Connector is not a universal driver or a universal connector, and it doesn't create a one-size-fits-all connection to REST APIs. Instead, it codelessly builds enterprise-grade connections to the data and that your customers need. So enough of the sales pitch and the slides. I want to turn it over to Ken now so that he can walk you through a live demo, and we can show you just how easy it is to get up and running with this. So, Ken, let me give you the ball here.
All right, thank you, James. And so, as you already have been aware from your customer requests, the ability to effectively work with REST APIs is becoming more and more critical. REST APIs are becoming a key construct for microservice architectures, data sharing, and to provide content across mobile and web applications. And a majority of the time, there's been a shift from REST APIs returning XML to JSON now. And so JSON data, whether it's simple or complex, can be difficult to work with, and generally will require some type of coding in order to parse it and convert it to a format that can be used with SQL-based tools. And so your customers have a few options in front of them. They could code a solution using Python or any other modern language and convert the JSON to a format that can be consumed with ease. They could make use of a web connector SDK and code a solution that may be only relevant for a single API. Or they may want to go back to direct database access, which allows them to fully use their SQL toolbox, but IT doesn't necessarily like this anymore from a governance perspective. And all of these options really require some form of coding, maintenance, time, and are often considered point solutions. So today I'll be going through 3 different APIs, and I'd just like to really highlight a couple of the great features that we were able to deliver for the autonomous REST connector. So the first API we're going to take a look at is a public API. It's from the United States Geological Survey. And it essentially returns seismic activity for a given set of filters. So if I run this in everybody's favorite API application, you can see that I'm getting data for the month of December, and I'm returning 2,000 records. If we take a look at the JSON data that gets returned, you can just see I have a fairly flat list of key value pairs, and it's not very complex. And I have roughly 2,000 records here, fairly simple. And so one of the more difficult aspects of business analysts, data scientists, or ETL developers that want to leverage the use of REST APIs is the fact that there is no context behind the data. And that context is metadata. On the surface, everything looks like a string. And even more difficult to detect would be the relationships within the data. And so your customers and our customers as well are used to working with SQL in a tabular or relational format. So how would they go about trying to analyze this data? Well, they would go record by record, row by row, and column by column and try to understand what they're working with. And so right here, I have that same data in a tabular format, and you can see exactly what we were looking at, but instead of JSON, it's being returned in a SQL editor. And if you're guessing, well, Ken's probably using Autonomous REST Connector, you're exactly right. So I'd like to show you how I got there. And so the intelligent sampling is one of the first features I'd like to highlight right away, is our connector is able to look at the data returned from the REST API. It can assign column names, table names, data types, and identify relationships within the data. So you can see now we have position, type, magnitude, place, and so on. And you can see their associated data types. And that's a much different view of the data than what we saw getting returned from the JSON. So if I'm a data scientist and I want to work with this REST API, I already have a lot more context of the data. And so with that context, I can submit a SQL query because that is my language of choice. And what gets returned to me are the results from the REST API in my SQL editor using the exact SQL. It's just a simple select statement where alert is not null and the magnitude is greater than 5. So these are big earthquakes that we're going to have some type of financial or human impact for the month of December. And it looks like it returned about 9 results. So super easy to use. And so let me show you how fast I can create a connection to a different API, retrieve a different set of data, but use the same SQL query. So I'm going to create a new connection. I've already configured my autonomous REST connector. The only 2 things I really needed to do was supply a location as to where the jar file is located and the driver class. That's what you essentially have to do for any JDBC driver. I'll click Next. And the only thing I need to do here is supply JDBC URL. Click Finish. I'm going to run the same exact query that returned 9 records. Open up a new SQL editor, paste that same query here, execute it. And so you can see for the month of November, it was a little bit more active. We have 16 records. But within a time frame of 30 seconds, I was able to create a new connection, only supplying a JDBC URL. I was able to supply a SQL query get that data back. And within that, we were able to sample the data, identify the table names, the relationships within that data, and also the data types itself. And so I want to look at one more query here using the December data. And the only thing I really changed here that I want to highlight is the fact that we have this position. We have this position column. And this is one of those things about our intelligence sampling that I like to highlight is the fact that we added this as a column because we were not able to identify a primary key. So how do you find relatable data within a REST API or any type of SQL query? It usually needs to be some type of primary or foreign key relationship. And since we weren't able to identify any type of relationship, we were able to create a unique column with unique values so that you can write SQL that makes sense, so that there are relationships within the data. And so this is the same one. So very simple, high-level overview of one of the APIs that shows the benefits of how quick and easy it is. I didn't have to write any code, and I was able to get up and running within 30 seconds. So let's go to a little bit more of a complex scenario. This is another public API. It's SpaceX. And I remember, I hope a bunch of people on the phone have seen this, the video where the two boosters were coming back down from the launch, and they landed simultaneously on top of a barge in the middle of the ocean. It was amazing. And they made it look so easy. And so hopefully I can make this look as easy as well too. And so this is a SpaceX API. It's publicly available, and it allows me to get information from SpaceX related to rocket launches, ships, cargo, payload, missions, and so on. And if we take a look, we have about, maybe 9,700 lines of JSON being returned for only about 74 records. So if you're trying to think about how your customers would actually work with this data and how would they analyze that and identify data types and relationships within this data, it's going to be a lot more difficult, especially if I had to code a solution on my own using Python or C# or any other modern day language. And so if we just take a look at a top level record here, you can see that it's fairly complex. There's multiple sets of hierarchy here. And so I want to just show what we do during the sampling process here. So before I do that, there are a couple other options out there available to some of your customers. One of the options is the fact that there are a lot of converters out there that can convert the JSON to a CSV file format. And I did exactly that here. You can see that I've got my 74 records here. And it's great in the fact that it can convert to a CSV format, which can be used with most SQL type-based tools. But there's one main ingredient missing. And that if I scroll all the way to the end, all of the data that contains the relationships is gone. So if you have a report that's doing a join across multiple tables, that's now abstracted out using a REST API, you lose that information. Your SQL, the SQL that's being generated, whether it's by your ETL or your BI tool, can no longer work. So let's take a look at what the autonomous REST connector was actually able to do here. So through the sampling process, we just make a single call. It's just a single endpoint that we're doing sampling. We were able to create 8 different tables here. Now, the table names are dynamically generated based upon our sampling techniques, but the main parent table, after doing some quick analysis, was V2 launches. And V2 launches will have a bunch of different child relationships with ships, payloads, mission, customers, and cores. And you can see we were able to take this fairly complex format here and identify all those different relationships into this relational model. So this is the primary key, and we have a bunch of other different relationships too. But 2 tables I'd really like to focus on is my customers table, which is a list of all the customers that SpaceX currently has today. We have roughly 85 records here. And also my payloads table. If I take a look at customers, the metadata for my customers and my payloads table, I can see that there is a relationship between payloads and customers. So what that allows me to do is run a join across this data. And so the great thing about this is that if I do have, some enterprises have hundreds, even thousands of BI reports. And if they're also going through a modernization effort, they need to ensure that their SQL-based tools can also seamlessly work. And that's what the Autonomous REST connector does, is if your software package or portfolio is generating SQL queries and they need to start being used against REST APIs, this will allow you to do just that. Let me just start up my SQL editor really quick here. It crashed. That's been happening a couple times today. So it's a little bit of Moore's Law. All right, great. And so let's just go back to this inner join just to make sure that I can submit the query so I'm not doing anything under the covers here. So imagine if you had a report and you're in SpaceX and you wanted to summarize the total payload that has been launched into space by customer. So I'm doing an inner join on both my customers and my payloads table. I'm grouping by the customer, and then I'm just ordering using the descending order by payload mass. And so I can submit simple SQL queries. I can submit complex SQL queries. All of that is capable within our SQL engine on the connector. We're totally SQL 92 select compliant. And so that's a great example to show you the advanced techniques that we can do for sampling, creating that metadata, defining those relationships, and allowing you to carry on seamlessly between the SQL world and the REST API world. Now, the last API I like to take a look at is Yelp. Everybody's heard of Yelp. You can get reviews, you can get location information, you can get ratings on all the different restaurants, and even businesses within your area or any area pretty much across the globe at this point in time. And so I want to dive a little bit deeper into some of the more advanced features, but still focusing on basically intelligent sampling and relationship identification. But here's where the Codeless aspect comes into play. Many times as we talk to customers about this product, they're not going to be working with just a single API. They need a way to work with tens, maybe even hundreds of APIs and find a way to sample all that information. And so this is just a very standard configuration file. The configuration file is just a parameter on the JDBC URL. And you can see that I have 3 endpoints. This is just key value pairs, table name, endpoint name. So I'm looking at both categories, events, and businesses. And so I can just go into Postman, run a quick get on this API, and it looks like we're returning a whole bunch of different lawyers in the town of Cary, North Carolina. That's where I live. And so let's go into my SQL editor. I just want to show you one thing about the connection string. Is if we take a look at this connection string, it shows you this different authentication method that we're using. We have multiple authentication methods, either no authentication, basic, token-based, which is what we're using right here, which seems to be a fairly popular method across all these different public and private APIs, and also header-based authentication. And so I'm going to run this select statement, super simple select statement, right? Let's get all the rows getting returned from that API on the businesses table. And you can see that there's a couple parameters here, Cary, North Carolina, and lawyers. Now, the great thing about Autonomous REST Connector is that we're able to do push downs for filters. So a lot of the time in the real world is that APIs are parameterized. You need to provide various criteria to change the way you get the data back from the provider. And so this allows us to provide a tool to our customers so that they don't have to create a new connection for every single different set of parameters that they want to work with. We can actually provide pushdown capabilities and also paging capabilities. So very briefly, within this configuration file, which gets automatically generated for you, you do not have to hand code this. This is the output from the sampling process. These two fields here, location and category, are pushed down. When they're pushed down, it means that I can use them in a where clause of a SQL statement. And if I run the same query using a filter, keep your eye on this business category column. What we did is we called the same API, but the query was parameterized. So instead of using North Carolina, we're now using a different parameter called 27513, which is just the zip code. And the same thing happens with paging. We have a very easy way to tell us how you want the data to be paged, whether it's row-based paging or page number paging. So super easy. So those are really 3 examples to show you a very low-code approach and a high-level view of our intelligent sampling so that you can very quickly and easily get up and running and seamlessly work between SQL and REST API.
All right, Ken, thank you so much. That was a great demo. I appreciate it. I don't want to take up too much more time, but I do want to leave you with some key takeaways, and then we're going to jump into the questions. 4 key takeaways. 1, Arc is fast, and Ken did a wonderful job of being able to demonstrate that. It can be set up and it can be configured in literally just about a minute. 2, Arc is codeless. Autonomous REST connector requires no coding to establish a live, powerful connection between data sources and applications. 3, Autonomous REST connector is intelligent. Using intelligent sampling, what I call the secret sauce, this product can infer the right configuration for the API connection. And 4, Autonomous REST connector is customizable. It offers abundant opportunities to customize how APIs are configured. So you're always able to connect with the data in the way that makes sense for you and for your customers. So I'm just going to leave the screen up here. And at this point, I'll turn it over to questions. And I know we've had a few questions come in. So Ken, let me jump into those real quick. This is actually a really good question. And I think I'm going to ask it of you, Ken. Can you talk a little bit about what it takes to package these connectors that are created for vendors that want to use it as an SDK or develop package connectors?
Sure. Yeah, very good question. So in terms of what actually what has to be delivered to your customer, if your current Progress customer already today, the delivery of this JDBC driver is exactly how the rest of our drivers work. So there's really no differences there. If you want to deliver custom created connections, essentially you need to deliver both the jar file, the JDBC connector, and also the configuration file that I really briefly highlighted.
Okay. You talked a little bit about paging. Are we able to collect hundreds of thousands of rows of data, or is that really kind of stretching the functionality?
Yeah, very good performance and performance question right off the top here. And so we do a lot of performance testing for the connector itself to make sure that it's competitive and also performance as well, since we've set the standard for performance as high as possible for the last 20 years here. And so we do performance testing. Sampling 100,000 rows could take a little bit of effort. I think the approach to that would be to maybe sample a subset of rows of data like that, and maybe come up with your configuration file and tune it if you need to. But really, every API service or provider out there is different. So if your provider would be able to return 100,000 rows of data without bogging down their system, certainly possible.
And sort of tangentially talking about paging, how do you handle various REST API paging mechanisms?
How do we handle? Well, we support 2 different paging mechanisms. One is row offset paging, and the other is page number paging. And one of the more difficult concepts of REST APIs is the fact that right now it's essentially the wild, wild west, right? There is hundreds of different ways to really implement paging on the back end. And so we have 4 parameters that you can define within your configuration file to determine where does the first row start, what is the offset parameter, what is the first page number, how many pages of data do you want to get back. And so we have a very easy way to plug that into the configuration file to create paging for you.
And I don't know if you want to talk about this or if you want to necessarily show it, but a really good question here about configuring Autonomous REST Connector, maybe on the setup.
Yeah, so the basic configuration of the connector requires two main parts that almost any JDBC driver needs, and that would be the driver class name and also the location of the jar file. Other than that, once you have that set up, the only thing you really need if you're not doing any type of authentication is you would need a JDBC URL. If you know how to construct a JDBC URL, you would be able to easily configure this yourself. There is documentation available on our website that takes you through all the different parameters that the JDBC URL supports, but very easy.
Got it. Tell me about OpenAPI or Swagger. Are there plans to leverage OpenAPI or Swagger?
Good question, and kind of goes back to the wild, wild west of REST APIs. There are a couple of specifications that we have on our short-term roadmap that we would like to support in terms of intelligent sampling, because a lot of what these specifications do, especially like if you're a Progress Open Edge customer like JSDO, or if you're familiar with OData, which is a very popular implementation of REST, they return a lot of metadata information. That metadata information can be critical to the sampling process. And so a lot of these different specifications, whether it's OpenAPI, Swagger, OData, or JSDO, are definitely on our short-term roadmap.
Actually, I believe that covers all of the questions that we have. That's all the presentation that we have today. I appreciate everybody joining. And Ken, thank you for the wonderful demo and for answering these questions. If you have any other questions or want to reach out to us, you can always reach us at www.progress.com. Otherwise, I hope you all have a wonderful afternoon. Thank you.